next one. So here we're going to talk about equations of line modeling. Modeling in math just means word problem. That's what it means. I can hear you all groaning. I get it. Math's not fun enough when it's just straight numbers, and then we're going to add in a whole bunch of words and red herrings and all this other stuff. All right, so let's get started here. So here we have the point slope form of an equation. So this is of a non-vertical line. Notice this needs to be non-vertical. If it was a vertical line, we have an undefined slope and we can't use this. So the point slope form is probably not the one you've seen the most. The one you've probably seen the most is slope intercept form, right? And this is what we just showed, right? Here's my slope, here's my intercept, and you know how to graph this. The point slope form is the best form for a line if you know a point. If you know, so here, it's the easiest one to form an equation. That's the point of the point slope, is to make equations, right? Because if I know 2 points, I can write the equation of the line. If I know a point and the slope, I can write the equation of the line. Here, if I know 2 points, yeah, I can get to this point. But in order to get to this point, I need to go through this. So let's just start here. So point slope form. So here we're going to go ahead and do this. So here we'll have y minus, here it'd be minus minus, so it'd be plus 1 equals m, which in this case is 3x minus x1, which will be right here as 3. So technically, this is the point slope form of the line. Just for kicks, we're going to go ahead and simplify it to the slope intercept. So here this becomes 3x. I move in the 3, so this will be minus 9. I'm going to add minus 1 to both sides, and so I'll have y equals 3x minus 10. Okay. Here. So go ahead and do this one, and then just tell me what the y equals something x plus b. So go ahead and do this one and get it all the way into, let me zoom out just 1 second. Go ahead and get it to this one. Here we're just going to put these all up, so I'll just say C above. We're going to just do all these up top. And so once you get this into y equals form, mx plus b form, go ahead and post what your answer is. And once I have about 5 or so posts, we'll move on. And now who's texting me? Hello. There we go. All right. So we have 2 people have answers. All right, so let's work through it. Seeing how we got some answers. Remember, everything you post in chat is correct because you're participating. All right, so here we have y minus y1, which in this case is 2, equals m, which is negative 1/2 x minus a fourth, or 4, right? Then we're going to distribute the negative 1/2. So I get minus 1/2 x. This goes into here, so the negatives and negatives, so this becomes plus 2. Let me do that a teeny bit slower. Minus a fourth times minus 1/2 is the same as positive 2, because here the 4 just goes on top. You can kind of write it this way if it helps. So negative 4, so negative 4 times 1 gives you minus 4. let me actually do this teeny bit slower. So minus 4 times negative 1/2. Notice here, this I can write this way. Here I'll get minus and minus, so that gives me a positive 4 over 2, which is the same as 2. Here I'm going to add 2 to both sides, and that gives me negative 1/2 x plus 4. Okay, so yeah, most of you got it. Most of you got the halves. Some fraction problems, but that's probably going to exist for a second or two. All right, so now that we've done all this, right there, we can find equation if we just know 2 points. Well, do I know? So here, do I know what my slope is? No, but I can calculate it. So m is equal to 4 minus 2 divided by 0 minus 1. And so here I'll get positive 2 on top, negative 1 on the bottom, so I get minus 2. And does that make a lot of sense? Yeah, if I go from 0 to 4, if I go the next one over, be 1 and 2. So yeah, so here's my slope. Now, I get to choose which point I want to use. I'm going to use this point. The reason I get it, because here I get 2 points, so I can pick either point, it doesn't matter. I'm going to choose this point. Why? There's a 0 in it, and a 0 makes just life easier. Because here I'll have y minus 2, my slope, which is, oops, hold on. No, I won't. I'll have y minus 4, Here I'll have my slope of negative 2, x minus 0. Well, x minus 0 is just x, and so here I can just add 4 to both sides, and I'll get y equals negative 2x plus 4. And does that make a lot of sense? Yeah, I have my intercept. There's my intercept, right? That's my y-intercept. And so here I can easily check this is correct. So go ahead and give this one a try. Find the slope and then calculate what the y, put it into y equals mx plus b. And then go ahead and once you have that, put that into chat, and we'll check it together. I do want you to watch me do one, and then you try one. That way, if you have dire questions, you can ask me. All right. Has anyone got an answer? All right, so we get, I use the point 2, 2, so I don't know. Well, you can use either point. Either point gives you the same answer. All right, so everyone's mostly in the coordinates. It's 1/4 x, 1 1/2, 2.5, or okay. So let's figure out what the other point is. Let's do that. All right, so let's just start. So find the slope. Here I'm going to have 2 minus 1 on top, so I'll have 2 minus 1. Here I'll have 2 minus a minus 2, so it'll be 2 plus 2. That gives me 1 1/4, so there's my slope. Just for fun, let me zoom in. That way I have a little bit more room to work. I'm going to use both points, so I'm going to use this point here and this point here. All right, so here we'll have y equals, y minus 1 equals a fourth times x minus plus 2. So here I'll get y minus 1 equals 1/4 x plus a half. I'm going to add 1 to both sides, and then I'm going to get y equals, that is not a 4th x. I said a 4th x. Did I write it? Not even a little bit. Plus a half. I'll add 1 to both sides. 1 plus a half is 3 halves, and so I'll have a 4th x plus 3 halves. Okay. Let's do it on this side. Here I'll have y minus 2 equals a fourth of x minus 2. Here I'll get y minus 2 equals 1/4 of x minus a half. I'm going to add 2 to both sides. 2 to both sides. So 2 halves is really, or 2 is really 4 halves. So 4 minus 2 halves is 4 minus 2 halves is 3 halves. And so it's the same. Most of the time, try to keep it as a single fraction. Some of you wrote 1 1/2. That is correct. I just don't, I was just taught never to do this because this could be 11 halves. This could be a lot of other things. I just try not to have what they call mixed fractions. Just try to keep it as a single one, just to keep life easier. I think the computer will force you to type it as a single one. So does that make sense? So either way you did it, you got the same answer, right? Both of them give you this answer. So it doesn't matter. You'll get some more practice in doing this. And we've always done that. Technically, when I just say write an equation, these are equations and you could be done. Both of them are true. And both of them end up being the same thing. All right, let's go to the next set. Let me just see what I have to do. Oh, good. All right, so this one we're just gonna, all right, so I'm gonna briefly touch on this. I don't think your book goes too much in detail on this, so I won't belabor it too much. So here's what they call either the general form. I know this is the standard form. So I know this as the standard form of ax plus by plus c equals 0. This form is useful to find intercepts and also to graph. Let me explain why. So if I want to sketch the graph of these and find the intercepts, well, remember what it means to find the intercept? It means, you know, the x-intercept is where y equals to 0. Well, if y equals to 0, here I have 4x minus 2 times 0 plus 8 equals 0. Well, so this is just for x plus 8 equals to 0. And so if I move the 8 over, I get x, or 4x equals minus 8, which means x equals 2 minus 2. So here I have the point -2, 0. Minus 2 and 0. Here we can do the same thing for the y-intercept. Remember, this is where x is equal to 0. So here I just have minus 2y plus 8 equal to 0. Here you can buy what they call by inspection, just by looking at it. If I have minus 2 of what plus 8 would be the 0, well, the what's 4, right? Y equals to 4. And so here I have the point 0, 4 is my y-intercept. So I have that here. And then I can just draw, oops. badly drawing a line. Oh, here I can just draw it. And so the reason this is useful, because if you set 1 equal to 0, you're just left with a really quick equation. And since it's linear, you might be able to do it in your head. If not, it's perfectly fine to crunch through it. Same thing here. Same thing here. Here I'm given another one. Here my x-intercept is where y equals to 0. So I set y equal to 0, so I pretend this doesn't exist anymore. And so I have 2x minus 12. Or 2x minus 12 equals 0. That means x was 6, right? And so here I can just quickly say x is equal to 6. And so I have the point 6, 0. If you want to do it in your head, you can do it by hand. I'll do the y by hand this time. So the y-intercept is where x is equal to 0. So I pretend this doesn't exist, right? And so here I have 2 times, plug in the 0, because I know what x is. I set it equal to 0, minus 3y minus 12 is equal to 0. Well, what can I do here? Well, this is just 0. So I'm going to move the 12 over, so I'll have minus 3y equals a positive 12. So add 12 to both sides. That's what I'm doing. Then here I'm going to divide by minus 3. Divide by minus 3. I get y equals negative 4. And so here, my x-intercept, my y-intercept, down a little bit, is x is 0. And then y would minus 4. So here I have minus 4, 0, which is my first point. And then I have 0, or 6, 0. Second point, and then I have this, and then I have this line. Okay. It's just something to see. I don't think the book asks you too many questions about this, so just something you see. And can I put this into slope intercept form? Oh yeah, sure, right? So let me just do that real quick for the last one here. So can I put this in slope intercept form? Sure. So here we have 2x minus 3y minus 12 is equal to 0. So here, we move this over. So we're going to add the 2, oops, I lied. We're going to minus 2x to both sides. We get the x on one side. We're going to add 12 to both sides. So I'll have minus 3y equals minus 2x plus 12. And then here we divide out by the 3, divide by the 3. We get y equals minus 2 thirds. Oh no, minus and minus. This is negative 3. Sorry. So that becomes positive 2 thirds x plus 4. And so here we're at 4. And then I'm going to go over, I'm going to go up 2 and over 3, and that's my next point. I'm going to go up 2 and over 3, and that's my next point. And so, yeah, this works out fine. Okay. So this is something more for you to see, not to work with too terribly much. Then I'll leave that up for a second, and then we'll go to the very last one. And this is where I think I'm going to give you extra practice this week. And doing stuff. All right, so does that make sense? The whole point of, zooming out. The whole point of the standard form is to just, once you get a little bit better at it, you can just say, oh, I know what the intercepts are. I set this equal to 0, so this must be, so the y-intercept must be 4, because that zeroes out the equation. Actually, sometimes it's easier to have it as this. This is also standard form, or minus 8, where you move it over. So if this is 0, in order to make that equal, in order to make this equal, you say, okay, well, that must have been 4, and then, oops. Then if you 0 out this, in order to make that equals, oh, that must have been minus 2. So, okay, let's just do the last one, because this is going to take a second. And yeah, technically we still have 20 minutes, but I'm going to do about an hour every time with you guys. All right, so 2 parallel lines, or 2 lines are parallel if and only if they have the same slope. And then 2 lines are perpendicular if and only if the product of the slopes is -1. This is how the book I pulled it from. There is another option here. You can have a zero slope and an undefined slope, aka a horizontal line and a vertical line. Those are also parallel. So this if and only if means if this is true, this is true. Or if this is true, this is true. This is the one case where this breaks. And so technically, even though books write it all the time as if and only if, it's not necessarily true, but it's mostly true. It's two non-vertical lines, yes, would be true in this case. All right, so let's do this. So let's determine if the lines below are parallel, perpendicular, or neither. Notice that 99% of the lines should be neither, right? Now, when we ask you questions, by design, there'll be more. But most lines, if I took two lines from the ether and plopped them on a piece of paper, chances are it's neither, okay? And give appropriate justification, just state why we know. So these two lines look, oh, hold on real quick. Have you guys seen these symbols before? Oops, wrong one. This symbol and this symbol for lines for parallel and perpendicular. Have you guys seen these before? Yes, no, maybe? I fell asleep. It's Monday morning. No, yes, okay. You've seen the first one, but not the second one. Okay, this just means parallel. The lines are in parallel, and these lines are perpendicular. That's all it means. So if you've seen them before, it's great. If not, you've seen them now. This isn't a geometry proof class, so you don't have to worry about that. Do you guys ever do it? Have you guys done the geometry proofs where you had to like prove that this angle is the same as this angle and all that stuff? Yes? Okay. Did you love them? Sadly. I'll take that as a no. I love proofs for some reason. Yeah, some people like them, some people don't. It depends. I thought they were fun little puzzles some days, and some days I'm like, oh, I'm just too tired for this. Because some days you see it or you don't. You're like, I got nothing. All right, so let's find the slopes of the line. So the best way to do this is to find the slope of the two lines. Just for kicks, we're going to call this line 1, this line 2, and might as well label all my lines. That way we know which one we're talking about. Does it matter which one we label? No. So here, the slope of this line, I'm going to choose this point here and this point here. Now, could we calculate it via points? Yeah, sure. Do we need to? No. So I'm going to go over 1, 2, and I'm going to go up 1, 2, 3, 4. So this has a slope of 2. I'm going to choose this point and this point. I'm going to go over 1 and up 1. So this also has a slope of 2, or over 1 and up 2. So since these have the same slope, these lines are parallel. All right, let's do this one. So here we have line 1. I'm going to choose this point and this point. So I'm going to go down 1, 2, and over 1. So this would be down 2 over 1. So the slope of line 1 is -2. Here I'm going to go over 1, 2, and up 1. So this is the slope of a half. Notice that 2 times, or -2 times a half is equal to -1. That means these two are perpendicular. Okay. So for figure 5, go ahead and find the slope of line 1, find the slope of line 2, and state if it's parallel, perpendicular, or neither. I'll give you guys a second to work on that. And then once I have about 4 people who answer, we'll move on. This last part down here is the rougher part, and so we'll go over it slowly. All right. Okay, so you have the slope of the two lines. So what does that make it? Is it parallel, perpendicular, or neither? Neither. Okay, so yeah, if I looked at those lines, these two lines at a glance, it's like, yeah, they look perpendicular, right? But when we actually dive into the slope, that's why we need to do this. So we go in, so it's over 1 and up 1, 2, 3. So that's 3. Here I'm going over 1, down 1, over 1, down 1, so that's -1. Here, if I multiply these two together, I get -1 times 3 gives me -3. Well, that's not -1, so this is really neither. This is neither. They look perpendicular, but it's really neither. And so even though they intersect at close to 90 degrees, well, not that close, but decently close, right? So here, okay, so parallel, perpendicular, neither. All right, so find the equation. And so this is a question they love, the department absolutely loves to give to students in the 126, the 120s, the 124s. Just one of their favorite questions of all time is find the equation of a line given a point that is parallel. They'll give you either parallel or perpendicular. We're going to do both in this case of a given line. So here we have a line, right? Notice here, what's the slope? We'll work through this one together, and then I'll show you how to do this one. What's the slope of this line for A? What's the slope here? Does anyone have a guess? Okay, so a lot of you are telling me it's -2/3. That's the slope of the line. Okay. Is that on the x? Isn't -2/3 on the x? No. Where's the x on this? What type of line is this? What type of line is this? Y equals -2/3. Does anyone know what type of line this is? Yeah, it's a horizontal line, right? If I graph that, very good, very good. So this is -2/3. We'll just y equals -2/3. And so technically I can have plus 0x, right? That doesn't change anything, right? And so the slope here is 0. And so here, my m for this line is 0. So for the parallel line that goes through this point, I need a slope of 0, and it goes through the point of 1, 2. Well, I can just plug that into my formula. Y equals -2 equals 0, x minus 1. Well, 0 of x minus 1 is just 0, right? So I get y equals 2. So y equal 2 is the parallel line. The perpendicular line would be 1 over 0, so that doesn't work. So here it's just the x value. Okay, so this is more of a concept question than a calculation question. Let's actually show a calculation question. So here I have it in standard form. I think on your homework it gets you to, it always just gives it to you in non-standard, or in mx plus point slope intercept form. I think it gives it to you in slope intercept form. I should double check, but we probably won't have time, so let's just get to it. So let's do this. In order to put this, I'm going to need to put this into y. Okay, so I move this over. If this doesn't make super sense to you, we're going to be working with this next time. And then if I divide out by 4, I get y equals 2. So 2/4 would be a half. X minus 7/4. We'll just leave it like this. So what's this? So this is how your homework's probably going to give it to you. I just want you to show you the steps. This is the homework, what the homework probably give to you. What's the slope of this line? What's the slope of this line here? A half, right? So here I have a slope of a half. All right, so the slope of a half, we're good to go. And so let's do the parallel line. So the parallel line will have the same slope. So we'll have a slope of a half, and I'm going to go through this point. So I can just crunch through that. So I'll have y minus 1 equals 1/2 of x minus 2. So everyone see where I get this equation from? Anyone lost at this point? Why isn't that minus 2x on the start? Oh, so here, this is not in point slope form. And so this is in standard form. So this minus 2 on the x is not the slope. You have to have it in y, and this y has to be clean in the sense that this has to have a 1 in front of it in order for this to be the slope. Okay? Good question. Very good question. All right, so once you're right here, so here we can just, technically I've given you the equation. Let's go ahead and just solve it out. So here I'll have y minus 1 equals 1/2 of x minus 1. And so y equals 1/2 x, because if I add 1 to both sides, that's what I get. And so this is an equation of a line which is perpendicular or parallel to this line here that goes to this point. The perpendicular line, notice for its perpendicular line, we're going to take what they call opposite reciprocal, opposite recip. Okay, cool. I probably spelled that wrong. I'm not going to lie. Probably spelled it wrong. And so if my slope was this, a half, right? I'm going to flip it, so it's going to be, so opposite reciprocal. So reciprocal means flip the top and the bottom. So we're going to flip that. So I get 2 over 1, and then I'm going to take the negation, so I get minus 2. Oops. M equals minus 2. So everyone, have you guys done that before? Opposite reciprocal, where you flip it and then take the negative for a parallel line or parallel slope? No, yes, no. Okay, so some have, some haven't. Let me just give, yeah, I still got 5 more minutes of class. Let me just give a quick demonstration. So here, if I have a slope of 4, the opposite reciprocal would be 1 over 4, and then I negate it. Here, if I have a slope of 2/3, the opposite reciprocal would be 3 over 2, and then I negate it. And then if I had one more of minus 1/2, the opposite reciprocal in this case would be to flip it. So it'd be 2 over 1, and then the negation, I'd negate the negation, so it'd be positive, which is just the same as 2. All right, now that we have this slope, we plug it into the same point here. And so I'll have y minus 1 equals minus 2 of x minus 2. Here I'll get y minus 1 of minus 2x plus 4. So I need to bring it into here and to here. And then we're going to add 1 to both sides, and I'll get y equals minus 2x plus 5. Okay, so this is my parallel line. This is my perpendicular line.